24 to 48 hours. That's not wrong exactly, but it's only true if you don't understand what's actually happening. Because propagation isn't some mysterious process. And once you see what it really is, you can make DNS changes take minutes. So, what's really going on when you change a DNS record? When anyone looks up a domain, the answer gets cached, stored, so nobody has to ask the source twice. Your computer caches it, your router caches it, your ISP caches it. Multiple layers all holding on to answers. And every cached answer has an expiration timer, the TTL, time to live. Measured in seconds, a TTL of 3600 means that cache holds the answer for up to 1 hour before asking again. This is why your change doesn't show up everywhere at once. You update a DNS record at 2 p.m. One ISP cached your old record 15 minutes ago. They won't ask again for another 45 minutes. Another cached it almost an hour ago. They'll see your change in 2 minutes. Someone who never looked up your domain, they get the new answer immediately. No global announcement, no sync, just caches all over the world, expiring at different times based on when they first asked. That's what propagation really is, cache expiration. And that 24-48 hours, that's the worst case when your TTL is set high and you just wait it out. But you don't have to wait. You can control this. Let's see how. The tool is Dig, pre-installed on Mac and Linux. On Windows, you can use NSLookup or install Dig through WSL. Number on the left is the TTL, seconds until this cached answer expires. On the right, your answer, the IP address. This is how you verify your change actually saved. When you change a DNS record, there's a source of truth, the authoritative server. That's where your DNS provider stores the actual record. Every other server is just caching answers from there. If you want to know whether your change saved correctly, skip all the caches and ask the source directly. First, find your authoritative server. NS stands for name server. This tells you who's authoritative for the domain. Now query them directly. The @ symbol queries a specific server, bypassing all the caches in between. If the authoritative server shows your new IP but regular lookups show the old one, your change is saved. It's just caching. Wait for TTLs to expire. If the authoritative server also shows the old IP, your change didn't save. Check your DNS provider's dashboard. Two more commands worth knowing. Different public resolvers, different caches. If they disagree, caches are just expiring at different times. And plus trace shows every step in the lookup chain, useful for deeper debugging. DNS returns different types of data. Here are the 5 you'll actually run into. A record maps a domain to an IPv4 address, the basic one. Quad A is the same for IPv6. You can have multiple A records for the same domain, returns all of them, client picks one. Simple load distribution, but with a limitation. DNS has no health checks. If a server dies, DNS keeps returning it. CNAME makes one domain point to another. Look up www, DNS says go look up example.com instead. One rule to remember, a CNAME can't coexist with other record types on the same name. But a CNAME somewhere, nothing else can be there. That's why you can't CNAME your root domain. You need email and verification records there. Some providers offer alias or a name as workarounds. Otherwise, use an A record. MX, mail exchange, where email gets delivered. Numbers are priorities. Lower means try first. If 10 fails, try 20. Wrong MX records, emails fail silently. Always check MX first when debugging email issues. TXT stores text, used for domain verification and email security like SPF and DKIM. Service asking you to prove you own a domain? Almost always a TXT record. And NS, which we saw earlier, tells you who the authoritative name servers are. Here's how to change DNS without waiting 24 to 48 hours. First, check your current TTL. 86400 is 24 hours. That's how long caches might hold your current record. Before making your actual change, lower the TTL. Set it to 300, 5 minutes. Keep everything else the same for now. Now, wait for the old TTL to expire. If it was 24 hours, wait 24 hours. Most people skip this step. Caches still have your old record with the old TTL. They don't know you've lowered it. Those old caches need to clear out first. Now, make your actual change. With the short TTL in place, caches expire quickly. The world sees your update in minutes. Verify by querying your authoritative server directly, then test from a few public resolvers or use an online DNS checker tool. Once stable, raise the TTL back up, 3600 or higher. And if you're stuck with a high TTL you can't change in advance, you'll have to wait, but at least now you know exactly why, and you can verify when caches are clearing. A few things that waste debugging time. Your browser caches DNS separately from your OS. Your operating system caches too. Your hosts file overrides DNS completely. Forgot about a test entry? DNS never gets asked. Check this if nothing else explains it. That's DNS. Cached lookups with expiration timers. Lower the TTL before you make changes, query the authoritative server to verify, and stop waiting 48 hours for something you can control. If this helped, please like and share. Subscribe for more such videos. Thanks for watching. See you in the next one.